Hey guys, I'm Mrs. Delavecchia, and before we start, I want to remind you to take notes using the guided notes that are in your unit packet. Those notes will be a part of your grade. If you have any questions, write them down and we'll go over them in class. So let's get started. Alright, so in this lesson we're going to learn about angles and how we measure them. So a few definitions in this lesson. But first let's review. What would you call this? Is it a line? Is it a segment? Is it a ray? Alright, if you said line, you were right. How about this one? A line, segment, or a ray? And that is a segment. And the last one is a ray. And keep in mind with a ray, what's important here is that the way you name this. So this would be ray A, B with an arrow on top because the arrow is going this direction. So this one, if you called it BA, that would be incorrect. All right, so an angle is the space between intersecting lines, rays, and segments. Usually two rays with a common endpoint, which we call the vertex. So the angle is this space in between here. All of this is the angle. And it is got two sides. Those are typically seen as rays, and then your vertex. The way we name an angle, you have to use 3 points, and the vertex must be the middle point. So we would call this angle RPQ, or we could call it angle QPR. But what's important is that the vertex is being named as the center letter in either case. All right, let's look at this example. We've got bunches of angles here. So let me just ask you, how would you name this angle? That could be angle BGA. You could also call it angle AGB. All right, let's try another one. How about this angle? Okay, that would be angle HGE. So we're starting with H, we're going to G, and then back down to E. Or you could also say EGH. But the important thing, on any angle that you name in this picture, G would have to be the middle letter, because you use the vertex of any of these angles. All right, when we have adjacent angles share a vertex and a side. So this side right here is in common. They both have the same vertex. This angle shares side C, or BC, and this angle also shares side BC. So we call those adjacent angles. All right, angle addition postulate. Again, remembering a postulate just means something we can know to be true without having to prove it every single time. So angle addition tells me that I can add this angle of 60 degrees and this angle 40 degrees, and the angles added together would equal 100 degrees. So pretty easy idea. All right, let's try one. If we know of the angle addition postulate, then we could get the measure of angle BLA. So that goes all the way here. So we simply add up 105 and 63, and we get 168 would be the angle of measure BLA. All right, if measure of angle 1 is 23 degrees, and the measure of angle ABC, so the whole thing is 131, Well, we've got to have some prior knowledge here. We got to know what this right here means, and that means that this is a 90-degree angle. So the whole thing is 131, so I've got 23 degrees plus 90 degrees plus some other degree, angle 3, is going to equal 131. Okay, so we're going to add up 9, 10, 11, 13 plus x equals 131. And then I'm going to say x equals 131 minus 113. So x equals 18 degrees. All right. Here's another one. Solve for angle BOC. So let's find that. We started at B, we went to O, and then we ended at C. So that's indicating this angle right here. Solve for BOC. If AOC, so that's starting here, going to O and then to C, so that's this angle, is 60 degrees. So all of it is 60. And AOB, so A to O to B, that's going to be 40 degrees. All right, well, you probably don't need an equation for this, but just in case, we'll call this angle X. So 40 plus X would equal the total, and X would equal 20. So you just need to be able to look at this and find what angle that is talking about. Here's one, a little bit harder. We've got angle CBD, so find that, angle C to B to D. That means we're looking at this angle right here. And solve for that. If ABD, the whole thing is 100, so from A to B to D, so this angle is 100 degrees. All right, well, what can we do here? If we know all of these angles, both of these angles equal 100, can I set up an equation? 4x plus 2 plus the other angle, 3x minus 7, equals all of it, which is 100. Then I'm going to combine like terms, so I've got a 4x and a 3x, so that's going to equal 7x. I've got a 2 and a minus 7. That's going to combine to make minus 5. Remember, we're doing an equation. We combine like terms on one side before we start to move across the equals. So next up, solving the equation. Add 5 to both sides. 7x equals 105. Last step, divide each side by 7. X equals 105 divided by 7, which is 15. Now, you might be tempted to think you're done here because you solved for x, but you've got to, and this is going to happen over and over again in geometry, you solved for x, but it's asking for the measure of angle CBD. That's this measure here. Well, CBD is an x, it is 3x minus 7. So I've got to take my value for x, 15, plug it in, and now I get 3 times 15 minus 7. That's what CBD is going to equal. So 3 times 15 minus 7, that is 45 minus 7, and that equals 38 degrees. So we could say final answer, the measure of angle CBD equals 38 degrees. All right, here's a problem just like that one. I'm going to let you pause, try this one, and see if you get the values. X equals 8, and the angle measure, ABC, equals 27. So try this one on your own, set it up, and see if you get those two answers. If you don't, then put a note in your question section of your notes that you need to ask about how this one worked out. All right, next definition, angle bisector. So if you went to dissect a frog, right, you would cut that frog up. So bisect, bi means two, so cut into two pieces. So when we bisect an angle, we're cutting it into two pieces, and those are going to be equal parts. And we can then say that a bisected angle, the two angles would be congruent. So this has been bisected, so each angle is the same degrees. Now, when we how do we note that something is congruent? We've got two ways: just an angle marker, that the same angle, or when you see, I tend to use this one more often, when you've got a single slash. So if you had a single picture, just like congruent line segments, we had the same idea. If I had another picture on the same problem, and I wanted to note more angles, I could just keep adding slashes. So I could say those two are congruent, these are congruent. So you match up how many slashes there are to know which angles are congruent. All right, so let's try a problem like this. All we have is this picture. So I got to know what these symbols mean. And these symbols mean that those are congruent angles. So I know that this angle equals this angle. So that's my equation. The problem is going to guide your equation, right? I've got 5x plus 11. That equals 26. And that's my equation. Then I just solve this. Subtract 11 from both sides. 5x equals 15. Divide by 5. And x equals 3. Now in this problem it said solve for x, so I'm done. I don't have to go back and substitute in. But if I did, let's check that out. 5 times 3 is 15 plus 11. That equals 26. So we can verify that our answer is correct, because when we substitute in, both angles are congruent to each other. All right, here's one for you to try that looks just like that. Set this up. AB is a bisector. So see what that would be and see if you can solve for x. If you get x equals 8, then you are on track. If not, if you're not able to get that, then put that as a question in your notes. So pause and try this one. All right, here's another example. Now our picture tells us I've got two angles, and I've got congruency markers, right? But what would I do with this? It tells me that the whole thing is 150. All right, well, if this angle is 4x minus 5, then I would know that this angle is also 4x minus 5, because it didn't give me a value there. And so equation that I can set up now is I'm going to add these two together. I've got that angle, and that is 150. So 8x combine like terms minus 10 equals 150. Add 10 to both sides. I'm just solving the algebra. 8x equals 160. Divide by 8, and x equals 20. And all you were asked to do there is solve for x. Okay, and the last thing we want to look at is how to use a protractor. So we'll practice this in class, but if I have an angle and need to actually measure its angle measure, that's what we use a protractor for. So I would line the protractor on my angle. So like here, my angle at the bottom. And say if I wanted angle BOA, this angle right here, I would line that up and I would follow where the angle is leading to. And so from 0 to 30, this would be a 30-degree angle. Okay. From AOC, I would follow that along. And I'm looking right here, this would be a 50-degree angle. And then all the way to here, I've got a 90-degree angle. Around to AOE, I would have a 120-degree angle. And then all the way to AOF. I've got a 140-degree angle. And you can see you have measurements. So you could measure from the left or the right just looking at the little markers there. One starts at 0 and goes to 180, and the other one comes back around. So that's basically how we'll use a protractor. You just line it up with one of your sides and then see where it indicates the degree measure is. All right, that's all for this lesson, and make a note of anything you have questions about, and we will see you in class. Bye-bye.